And we're back. It is a very unusual start time, 2:46. I figured we'll do some more problems. Probably should have done the day command. Yep. Yeah. Be calm today. So more interview prep. Second stream of the day. And it'll probably be short. Adam is doing more interview prep. More information about why Adam is doing this. Jobs, read this. Okay, cool. Yeah. Hey, Hamburger. Hey, Liddy. All right. So earlier, I think, hey, Lazy, I think the biggest problem right now is gaining momentum, because I think there's the capability to do things. I think there's been some learning. I think there have been some results. I think there's a whole lot of stuff that's going well, but I just, whether I'm streaming or I'm not streaming, I can't seem to do a whole lot of problems all at once. And I think part of that momentum maybe is getting wins. So for example, doing easy problems after I don't get a particular problem. Maybe I should try that. Midnight, wow. Yeah, I was gonna say UTC right now is, yeah, basically midnight. So you must be about 7 hours east. So maybe that's what we'll try to do. Yeah. After missing a problem, we'll go down in difficulty. Sounds like a plan. All right, let's do it. So problems, difficulty medium. Oh, it keeps doing this. The page apparently doesn't have to be part of the URL, which I'm fine with. I just never expect that. All right, so where did we go to last? Flip equivalent binary trees. Sounds like something we should do. All right, let's try it. There. For a binary tree T, we can define a flip operation as follows. Choose any node and swap the left and right child subtrees. A binary tree X is flip equivalent to a binary tree Y if and only if we can make X equal to Y after some number of flip operations. Write a function that determines whether they're flip equivalent. Okay. All right. What, Zoom? All right, I'm gonna go back to not reading chat for right now. So let's figure out how we're supposed to do this one. So let's think of a basic case here. So flippable trees. Base case is like 1 to 3 nodes, let's consider. So with one node, if they're the same node, then return true. Okay, so if it's more than one node, that means that there has to be a child here. And that means that the left subtree has to be equal to the right subtree, and the right subtree has to be equal to the left subtree? Yeah, I think so. I guess it's like only one node. I guess it's something like 2 trees are flippable if the root nodes have the same value and the left and right subtrees, and the left subtree of one equals the right subtree of another, or that they're the same, equals either subtree of the other. But that's not actually true. And either the left and right subtrees, the left subtrees and right subtrees of both are equal, or the left subtree of one equals the right of the other. I don't know how to write this more succinctly. And the left of the other is the right of the first. Yeah. I'll probably just say like tree 1 dot left. Yeah, even this is incorrect phrasing. Who cares about succinctness? Because it's not really that. Like, let's say we have 1, 2, 3, and over here we have 1, whoops, 3, 2. So these are flip equivalent. And the reason why is because the left of this is equal to the right of the other one, and the left of the other one is equal to the right of the first one. But that's not really true. It's that we have to run it through this function too. So two trees are flippable if their root nodes have the same value and either and their subtrees are flip equivalent. But that's not, man, I'm still getting the terminology on this wrong, I think. So let's look at one of the bigger examples here. So we can see that the ones are equal and the roots need to be equal. I guess we could do that here. If root 1 equals null, I'm not going to write out the condition for this way. I think this is silly. That I was going to say we could compare just the roots and compare everything beneath them, but that could all probably be done recursively anyway. So I guess if we do flip, so if the left child of one is equal to the right child of the other, then we will need to flip the values. Okay, that's what I kind of want to say. And either left and right subtrees are, so I guess it's like the left 1 equals left 2 and right 1 equals right 2. Or left 1 equals right 2 and left 2 equals right 1. And the left and right subtrees are flip equivalent. Okay, I think those are the conditions. So let's try this with some kind of basic cases here. So first of all, if the root nodes have the same value, so here they do, that's a prerequisite. That's very easy to check. And either the left and the right are the same. So if we had duplicated this over to here, let's say. So trees A, B, and C. And they're all flip equivalent with each other. So A and C are just the same tree. So this is saying that their values are the same. And then we want to check if the left and right subtrees are flip equivalent. So if a node is ever null, then the other node needs to be null as well. Do we want to traverse them both at the same time? All right, and then let's, I guess, go to this more complex example. So the root nodes are the same. This one has these swapped, and their left and right subtrees are flip equivalent. So the left subtree of this needs to be flip equivalent with the right subtree. And the left subtree is flip equivalent left 1 right 2 and is flip equivalent left 2 right 1. And then this one is flip equivalent left 1 left 2. Okay, now we're getting somewhere. Yeah, now we're getting somewhere, I think. So delete this. And so our is flip equivalent takes in tree 1 and tree 2. And I guess if both are null, okay, yeah, so something like this. I think this is probably pretty good. So the root nodes need to have the same value. Yeah. Okay, I think we did it. Let's try it now. So if they're both null, return true. If only one is null, return false. If otherwise, we just code in these conditions. All right, so let's code this. Left one equals root one dot left. Left two equals root two dot left. Right one equals root one dot right. Right two equals root two dot right. Okay, so now we code this stuff. So if left one dot val is equal to the other one, and the rights are equal, and is flip equivalent, flip equiv, left one, left two, and flip equiv, right one, right two. So it's all of that, or this. And we return that. And that's the code. So does this even work? Because I kind of doubt it. Oh, I have an error, unexpected token somewhere. Where? Here, apparently? A semicolon? I probably messed with the parentheses. Yeah, man. What am I doing wrong? We're going to be able to read this. I can just split it into two conditions. But I kind of want to examine this a little bit closer. So this was supposed to have that, yeah. And then the other one was supposed to have this. Yeah, probably. We're gonna try that. Oh my god, I'll never get this right. Oh no, this is actually correct. It's just that they don't necessarily have the children set. So we need to get the values. Actually, I wonder if we even need to do this part. Yeah, I don't think we need to do this because I think that's what these conditions are going to do. So let's remove those parts and try that. Oh, this is going to do more calls than we need now, but let's try this. We won't run into null errors now, at the very least. Hey, cool. Okay. So did that work? How do I get back to my... No, wrong answer. All right, and unfortunately, I don't know how are we gonna look at this. Try it this way. So tree visualizer. So expected false because these aren't the same trees at all, I guess. Let me take a look. Here was tree 1, and here's tree 2. Okay, now let's look through my code and figure out what this is doing. Okay, so the roots that get passed in originally are the same. I never checked their values. Yeah, whoops. If root 1.val is not equal to root 2.val. Okay, that I left off for sure, but I don't know if that alone will fix this. Oh no, it does. Okay, good. All right, so that wasn't too bad. That took a long time. Did I read CCI? Yeah, I have. Yeah. That's very trippy. Hey, Mr. Haldy. And hey, everybody. I'm doing very little, Mark. Very little. Like today was exactly what you saw earlier, plus however long it's been now, which is 15 minutes. So yeah, 2.5 hours, and however long the stream's going to be, maybe an hour and a half or something. That's pretty bad, I think. But yeah, I'm the same way. I think I need to build momentum better. I've thought of this the last couple days since last stream, and no way do I want to antagonize your enrichment. Maybe do some mock interviews or some easy ones like with a friend or your wife to get your confidence up. Yeah, I think that's a very good idea. I need to do more mock interviews. I need to schedule them for sure. And I think that that is the way forward. Can I judge the solution you proposed? Create an array of ordered lists representing each layer and check if the same layer of trees of different trees are equal. Yeah, the list representing the layers. I think that would work. Except for you're not really checking if they're equal. You check if you could reverse them to also be equal. But yeah, that would work. I think this is pretty clean because you can split this into the sort of the child problems here. And yeah. And maybe that's what they talk about here, recursion. If they have the same root value, we only need to check if their children are equal up to ordering. I don't know what that means. If they're null, then they're equivalent if and only if they're both null. Otherwise, if they have different values, otherwise we'll check if they're equivalent and there are two different ways to pair them. Yeah, so this is almost exactly the code I ended up with. And then canonical traversal. Flip each node so that the left child is smaller than the right. Call this the canonical representation. All equivalent trees have exactly one canonical representation. This is a pretty clever idea. But this only works... No, actually, I guess it always works. They just have distinct values. Yeah, that's pretty clever. Yeah. Pretty clever. Oops. Can I explain it fast? Yes. The answer is yes, it would work. Okay. So let's move on to the next one. Like I said, if I get the problems right, we'll just keep doing the medium ones, I guess. We've done a lot of binary tree problems. The thing that I feel a little bit weird about with binary trees is that sometimes I get to a solution, like this one. This took whatever. I mean, the stream's only been online for 17 minutes. So it took less than 17 minutes, which I still think is too long. But what if I didn't test this, or what if I had to think about it just by looking at the code? This might have been a little harder. What if this condition had ended up working? The code was cleaner without it. Turns out I hadn't needed it. So I don't know. I guess it was fine. Can I explain my code? There's a solution tab that explains all this stuff that you can check out because it's exactly the same as mine. So if you look at their solution, you should see. Okay, so let me also turn that on for a second. All right, next, check if a string can break another string. Okay, let's try this one. I'll put this back up actually. So given two strings S1 and S2 with the same size, check if some permutation of string S1 can break some permutation of string S2 or vice versa. What does breaking mean? A string X can break Y if... Okay, hold on a second. Two strings of the same size. Check if some permutation of string 1 can break some permutation of string 2. String X can break string Y if every character of X is greater than or equal to every character of Y in alphabetical order. I think that's what they mean by the greater than sign. For all I between... Okay, good, yeah. So AYX is a permutation of XYA, which can break to string ABC, which is a permutation of S1. Okay, I think I understand what's going on here. So we need to, the question is, can S1 break S2? No, wait a sec. AYX is a permutation of S2, which can break to string ABC. Oh, or vice versa. Okay, got it. So can you find a permutation of S1 and S2? Can you find permutations of S1 and S2 such that either breaks S1, S2 or breaks S2, S1? Breaks is defined as I equals 0, I is less than S1 dot length plus plus I. So if S1I is less than S2I, and in order to do this, we need to convert numbers here because this won't work in JavaScript. So we need some like alpha equals the alphabet, and then we say alpha dot index of, and then the number. Yeah, that's what we have to do. Or there's some other way of doing this. I always forget how this works. If you have a string and there's a function to get, char code at. Yeah, that's what we do. Char code at 0. Char code at 0. So if it's less than it, then return false. Otherwise, return true. So that's our breaks function. And I mean, I'm pretty sure this is correct. This I actually will test out. I just want to make absolutely certain that we're right about this. And then where'd the other code go here? So there's breaks. And let's just print out a couple of values here. Like breaks. And then what are the strings that we had here? X, Y, A, A, B, C. No, A, Y, X, A, B, C. A, Y, X, A, B, C. So that should print out true. Good, yes. All right. Whereas the opposite, A, B, C, A, Y, X, should be false. Good. Okay, yeah, so I probably did that right. Granted, I haven't even gotten to figuring out the problem yet. This is all just the definition of the problem so far. So, what are some approaches we can do for this? Well, one thing we could do is just test every permutation of A and B in, well, S1 and S2 in both directions. So like breaks S1, S2, or breaks S2, S1. But maybe there's a better way than this, because the way for us to do this, are they distinct characters? I guess it doesn't really matter if they're distinct or not. Because let's say we had like AAA and ZZZ. So what if we ordered them? What if we sort each string? Yeah, I think if we sort each string by characters, then we just have to iterate over them. And if one is greater than the other, then we're fine. We might be able to do this even better by some kind of hashing here that would hash such that if this is, it doesn't matter. Yeah, I think just sorting each string might be better. And then we take the string. Let's try that. So the algorithm is something like sort each string based on ASCII values. Were we told that it's all ASCII? Yeah, lowercase English letters. Yeah, so that's fine. So then it'll only be numbers from 0 to 25, or 97 to whatever. Or 95, I meant. I think. No, 97. 65 is capital A. So sort each string, and then when we iterate over it, we're going to have something like this, like 1, 2, 3, 3, 3, 6, 7, and the other one might be like 2, 2, 3, 3, 4, 9, 9. And so this one breaks the first one. At least I'm pretty sure that's the nomenclature they're using. So that'll be fine, but these could also have been like this, and then they could be such that they don't break, like 1, 3, 5, and 2, 2, 5. So what we could do is, as we iterate over them, figure out the first time we have a greater than or less than or greater than, and then enforce that all future ones fit that same operation. So that would work. Alternatively, what we could do is just we convert them to big ints and then just compare the ints. That would work. That's kind of the hashing thing I was talking about. In fact, that's super easy, except for that I don't know how to use big ints in JavaScript. We could convert the array of characters into big integers of base 26 and then just compare that for greater than or equal or less than or equal. No, that wouldn't work. Always, no, yeah, that wouldn't work. Anyway, it doesn't matter. Let's just do this. So this way works fine. So we're gonna sort them first. So we'll say like codes 1 equals map all of the characters of S1 to char code at 0. And then codes 2 is the same way. So now we have codes of just ASCII values, and now we want to iterate over them. I equals 0, I is less than codes 1 dot length plus plus I, code 1 equals codes 1 I code. I'm not even going to fix the spacing here. Okay, next we figure out if we locked in a value first. So we'll say like operator equals null. So if code 1 is less than or equal to code 2, then if operator is null, operator is going to be equal to less than. And in this case, it'd be greater than. No, it's less than, else if it's greater than. Otherwise, we just don't even care. So now if operator is not equal to null, then we enforce that this is the case. Well, let's just do it this way. And code 2 is greater than code 1, then return false. That's what we're supposed to do here the whole time, right? Just return true or false? Yeah. And the other case we have is if it's greater than, and then this is the case. Code 1 is greater than code 2, return false. Otherwise, return true at the end of all this. And that should be it. Yeah, I'm going to try running these. Okay, so let's go test this on my own machine. Yeah, now what are the tests we want to do here? This is true. So LeetCode, we have what? S1, S2. And what's the function called? Check if can break. And then we write our test ABC, XYA is true, and the other one is supposed to be false, ABE, I don't actually use the breaks function anywhere. But yeah, let's figure out at least if the codes are correct. There are some parts of this where I don't really consider this to be part of the algorithm. I mean, it kind of is. But yeah, that looks totally fine. So we at least did that part correct. Oh, I never sorted them. I wrote down that I was supposed to sort them, and I just never did that part. Yeah, whoops. Yeah. That's a minor mistake. Just a teensy tiny mistake. All right, so now that they'd be sorted, which I guess we could have kept this printing out. Yep, sorted and sorted. So what I wanted to do is as we iterate over these, and this is a part where I actually messed up the algorithm now, and not just some like careless mistake. So we compare them both. Neither is less than or greater than the other one. They're equal. So we just keep going. Then oh, you know what we could have said here? If operator, oh, we could have just done this here, right? If operator equals greater than, then return false. Otherwise, set it to less than. And then here, if operator equals less than, then return false. Otherwise, set it to greater than. And now we don't need these parts here. So it gets even cleaner. But I mean, it wasn't working to begin with, so it might still not be. Nope, it's working now. Okay, cool. Well, I must have fixed some logic error as part of that. So let's actually try to take a look at what the logic error was. And in the meantime, we'll paste in the code that I had over to here, and we'll submit that. Cool, it worked. It took a long time. Yeah, so maybe there's a better way. I should definitely think about that. But first I want to find out what went wrong over here. Because I must not have had the logic that I wanted. Code 1 is less than code 2. And we had, I don't know what they want anymore. We had these numbers. So they're not less than, they're not greater than, so these things won't be the case. So then we get to this one. Code 1 is less than code 2, and operator will be null, so we'll set it to less than. And now it's less than it. And oh, I wrote the condition wrong. Yeah, that was it. Okay. And in cleaning up my code, I found the issue there. All right. So let me read chat. Yeah, breaking a string is something they just made up, I guess. Hey, Fade. Yeah, I don't think it's a common case or anything. Did they mention sorting in the question? Oh, did they? Did they say don't sort? They talked about alphabetical order. I don't think they mentioned sorting. No, I don't think they mentioned sorting. Then again, there could be something better. Hey, Nitro. What I'm working on, yeah, if you take a look at either the today command or the problem command, you'll find out what's going on today. In general, it's just more LeetCode problems. This solution that I had was apparently pretty slow. How could we have done this better? We have to sort both strings, which is n log n. Is, is there a way we? I'm not sure if there's something better than that actually. Then we go through and compare. I guess we could. Maybe we could. Maybe we don't have to compare character by character. Maybe there's a way we could see if there's a break sooner. So let's say we had something like this and something like this. So all of the numbers plus 1. All numbers are the first array's element plus 1. So could we detect this better than in linear time? No. I think the answer is no. But I think this is part of where I could have come up with an ordering that let me just compare. Like, yeah, I think there's some way to, some form for our array to take such that we can just run a greater than sign on it. Maybe. It's very tough to do. Because if you just go based on lexicographical ordering, you'll always have one string appear either at or ahead of another one. But that won't tell you if it follows this breaking thing. I don't know. I'll look at the discuss part. Yeah. O of n. Oh, come on. I missed some like obvious thing. We just have to check for all characters if the count of all characters is greater than or equal to. D1C. Selections on counter. I see. I see how they do that. Okay. So they get the frequency of all of the characters first, and then make sure that wait. Oh, they do it both ways. Yeah. Okay, that's cool. That's a clever solution. Yeah. So you have a string like ABC and you have another string like XYZ. And so you form a hash map of there's one A, there's one B, there's one C. Likewise with X, Y, and Z. And then as you iterate over it, you make sure that none of them have an absolute, not an absolute value, none of them have a difference of a negative number. And that's okay because you're checking both directions. But if they both end up with a difference of a negative number, yeah, this is really clever. Would I have ever figured this out? Counting character frequencies and then comparing? I guess I could have. I kind of stopped when I thought I had a good solution because I thought it was at least better than the brute force. Oh, man. All right. Well, I think that's a really good problem. I'm actually upvote that one. I like that it has multiple ways to solve it. I should be upvoting more problems. Yeah. Well, I'm not really that bummed out about what I came up with. It just could have been better. Okay, let's go on to the next one. So we're here, display table of food orders. I think we looked at this one before, and I think I decided this just seems tedious. Yeah, this was the tedious one. We're not doing that one. Let's look at path with maximum gold. In a gold mine grid of size n by n, each cell in this mine has an integer representing the amount of gold in that cell, 0 if it's empty. Return the maximum amount of gold you can collect under the conditions. Every time you're in a cell, you collect all the gold. And it's positive, right? Yeah, can't lose gold. From your position, you can walk one step to the left, right, up, or down. Okay, cardinal directions. You can't visit the same cell more than once. Well, oh, okay. I was going to say, this is technically different from if you set something to 0 and allowed you to visit another time. Never visit a cell with 0 gold. You can start and stop from any position in the grid that has some gold. Okay, that's a good chunk of rules. So start and stop anywhere. Select all gold in a cell. Can never repeat cells or touch 0 cells. And can only move to cardinally adjacent neighbors. Yeah. Okay, so here they have a grid of 060, 587, 090. The path to get the maximum gold is 987 because you can't touch the zeros. Otherwise, you'd be able to progress over to 6 and 5 as well. All right, so this is one of those kinds of cases where you can't just go with a greedy algorithm, or if you do, you've still got to backtrack anyway. Because this 9 could be surrounded by zeros, for example, and then going and getting the 9 doesn't actually help you at all. Like if we had a grid like this. Now you go for the 9 and you miss out on 7, 8, 6. I didn't highlight that the right way, but it'd be like this. Yeah, so 7, 8, 6 would be the biggest one in that case. So it sounds like just a kind of naive approach here would be start at all non-zero tiles, enumerate all paths from those tiles, and take the largest path. I mean, I think that's it. This is potentially a very, very large operation. This is what, like O of n to the third, I think. Because we're going to pick every single tile that's non-zero, which could potentially be all of them. Then we're going to do every single path from that tile, which is probably O of n if n was a single dimensional array, so all the size of our input as well. And then we're going to... No, I guess it's only O of n squared. I guess technically I'm kind of cheating here by saying n. I guess this is like n is really equal to m times n. So I guess it's n squared. But it's really m squared n squared. O of n squared. I think at least. Yeah, now is there any better way of doing this? All paths from those tiles, take the largest path. Well, some paths are going to be the same. Like finding 687 is going to be the same as 786. Although it doesn't, for finding the solution, it doesn't really matter. But we have to enumerate every single possible path if we're going to do it this way, in which case we'll be, at the very least, doubling all the paths that we find. Is there another way we could look at this such that we don't need to search them all? Oh, this is gonna be really tedious to figure out. Let's do something really fast. Okay, so let's say we have a grid. This will take a second. I'm not going to draw this perfectly. Okay, there. So, and I'll just copy a couple of these off to the side. So let's say we have a grid and we had a cell here. I'll just paint these. We had a cell, something like this. So if you were to start on this blue square, that will never get you the best possible amount. Because at the very least, you could have started on this red square and gotten a little bit more, or you could have started on this red square and gotten a little more. So we only really care about the ends of the paths, but there might be multiple ends of those paths, and it might be harder to find those than to just solve the problem by doing every permutation. Yeah, honestly, this is the only idea I have so far. Is there anything else we can do? Maybe we just code this. Yeah, I'm probably going to do that. All right, so start at all non-zero tiles, and then enumerate all paths from those tiles and take the largest path. All right, well, yeah, let's just go do this. So we're going to say for, let's get like width and height. Width is equal to what? It doesn't really matter. Height is grid.length. Width is grid 0.length. And they're guaranteed to at least be 1. So we don't have to worry about these not existing or something. So then we iterate over the entire thing. Let y equals 0, y is less than height, plus y, x equals 0, x is less than width, plus x. So now we figure out the longest, or like most gold equals 0. Most gold equals math.max, most gold, and get gold xy grid. I'll just pass in the width and the height as well. Okay, so what does get gold look like? So that was started all non-zero tiles. We actually only care. So if grid y x equals 0, just continue. We don't care about that. All right, enumerate all paths from those tiles. So this one's a little bit tough, right? So let's say we took this grid and we had a plus shape. If we were to start here, we can only go, oh no, it doesn't matter, does it? No, let's consider starting here. We can only go down. And then I guess every tile that we visit, we got to consider the path leading up to that tile. Okay, yeah. So this is going to be really annoying. Yeah, so we're going to have to do something like this, like nodes to visit equals an array of objects where I'll make a quick class here. Say like node with path. This is still a dumb idea. So the node is going to be yx, and the path up to that is going to be nothing, I guess. Kinda doesn't make any sense. Maybe our node should be coordinates. And then when we get done with the path, we could sum it all up. No, we should keep track of the gold so far. The path only matters in so much as we're getting gold from it. So I guess we can just say this is gold. But we need to know we're not repeating an element that was already in that path at any given point. Sorry, I'm just trying. How about we code this a little differently? I'll say x, y, gold. Yeah, I might be doing this wrong. I might have to think about this a little bit more. Okay, so let's stop and think about it now, because I don't want to get farther in the code and do that. So when I enumerate a point, let's say we start here, I want to mark that as seen. And then whenever we find it again, I want to make sure we don't go to it. So in order to mark a node as seen, we just need its x and y. We can get like a hash of that node. Yeah, we can say like toString return this.x, this.y. All right, there. Now we'll have some way of keeping a set that will have all these things be unique by their coordinates. And then we keep track of the gold so far. Okay, this sounds reasonable enough. So I'm going to say like visited nodes is going to be nothing so far. And that can actually be a new set. Now, while nodes to visit dot length is greater than 0. This algorithm is going to suck. I'm already saying that now. If there's a better way, I definitely didn't think of it. So that's why I was coding this one. So say node to visit equals nodes to visit dot pop. And then we have to push that into the visited nodes dot push node to visit dot toString. Actually, I guess if it's already there, if visited nodes dot has node hash. So if it has the hash already, just continue. And then push it, which is not called push, it's called add. All right, so far so good. Then we want to get all the neighbors. Neighbors equals get neighbors grid x, y with height. All right, now we write function get neighbors. This is, all of this leads me to believe I'm doing this wrong because we've already written more code than like an elegant answer would have. But like I said, I didn't come up with a better way, so we're coding this anyway. So if x is greater than 0, then neighbors.push, and we probably want these to be nodes. I'll just make them coordinates for now. So x minus 1y. If x is less than width minus 1, then push this plus 1y. And then the same things here with y and height. There. And then return neighbors. So these are just coordinates. And then we want to add all of those. So for each neighbor, and this is going to be x and y coordinates. Where did x and y come from? Oh, there. Okay, well, we can call this like nx, ny. And what we want to do is we want to say nodes to visit dot push new node with path. So we have the new node, and then we add the gold that is there. So ny, nx plus however much gold we already had. Node to visit dot. All right. Then when we're done with this, we'll have, I guess if this amount of gold is more than what we've already seen, then at that point we'll check it here. Yeah. Gold equals node to visit dot gold. And max gold equals math.max gold, max gold. And then return that. All right, this sucks. Yeah, I don't think there's any other way to say it. It might work, but I don't think it's good at all. Let's run this. That part's a little unusual. Did I mess up? I missed a parenthesis. Okay, so we got 35 and we expected 24. That means I must have messed up a rule of traversal here. What does that look like? This one? So we're supposed to get 24, which is, yeah, these three. And we got 35, which is all 5 of them. Because we can't go to nodes we've already visited, and I didn't stop that, I guess. No, that's not what happened. It's that I didn't stop us from visiting nodes that have a 0 in them, so I did mess up the rules. So if it has that as a hash, or I guess if gold is 0 on this, that doesn't really work. I guess it's like neighbor gold equals this. And we just say if neighbor gold equals 0, return. There. that work? It still did the same thing. Uh-oh. Let's see. We start up here and we ignore all the ones that start with 0. So when we get gold, we know that we're on a node that has gold on it. So how are we pathing back to nodes? There are only 2 ways we could get to nodes that we've already seen. One is if I'm not checking this correctly. And the other is if I'm going through 0 nodes. So this should stop us from doing this one. And this should stop us from doing the other one. Huh. Okay, let's look through this a little bit more closely then. So yeah, let's try this out with this as our thing. So width is 3, height is 3. Let's start here. So x will be 1, y will be 0. And visited nodes is going to be an empty set. Nodes to visit is going to be a node with like x, y, and then however much gold is there, 6. Okay. Now we pop that node out of here. So this turns into our node to visit. Our node hash is going to be 1, 0. So now that is not in visited nodes, but we're going to add it here. So 1, 0. Then we get the gold. Gold will be 6. That'll be set to our max gold so far. Yeah, that sounds fine so far. Yeah. Then we get all the neighbors. This is fine. We could also check here whether the gold is 0. It doesn't matter where we check it. Well, one would use less space, I guess, but I don't care about that for right now. So the gold is 0. So we're going to ignore this neighbor. Oops, we're looking up here. We're going to ignore this neighbor and this neighbor. So we're only going to hit the neighbor 8. So we're going to push that as our new node. Nodes to visit dot push new node path. Okay, so our new node path is going to be the same x but 1 higher y, and then the neighbor's gold plus the current gold, so 14. Okay, yeah, cool, I guess, assuming I did this correctly. Now we get down to the next one, so we pop this node off, so it comes out of here, gets set into here. It is not in our visited node, so we're going to push that here, 1, 1. We get its gold is going to be 14, so max gold is going to be 14. We get all of the neighbors. At this point, we have a neighbor we've already seen before, which we're still going to push it. But then when we go try to process it, we're going to see that we visited it and just continue. Yeah, and then we're also going to push 5, 7, and 9. So I'm not seeing the problem from here, and I don't know how much farther I should go with this. So I guess let's just run this through the debugger. Yeah, I messed up something that I'm not seeing. And either way, like I said, this is pretty much garbage code. Like, you should never have a solution that's this long. Oh, I never even used a grid here. Well, we can just get rid of that then. Okay, so what do we pass in? We pass in a grid, and it's called get maximum gold. Stringify grid, and we test with this, and it should be 24. So if I run this on my own machine, we're gonna get 35 as well, right? Good, yeah. So why does it happen? Well, let's put a breakpoint here and find out. Inspect break. I apparently had insert on that entire time. Path with maximum gold. All right. So we're going to ignore this one because this is the 0, 0 position, which is a 0. But we're going to go to this one because this is the, what, the 7 or something on the left side? What is that one? A 5. This is a 5, right? Art thou a 5? You're a 6. What? Oh, I'm going to the right first. Never mind. Yeah, that's good. Fine. All right, so we call it get gold. And now we do a bunch of stuff. Now, depending on what kind of interview you're in, this might not be allowed. So we're gonna do this anyway. And we want that as well. Nope, nope, nope. That was supposed to be the word node. No, oh my god. I'm not clicking things correctly. This is supposed to be the easy part. Typing things in. Yeah. Didn't know if my wife wanted anything. All right. Then gold. And something else. Did I have another node here? Or another anything? No, I don't know. Grid YX maybe? No, I don't really need that. Okay, so let's go into this. So we pop this node off. We get 1, 0, and 6. That's totally fine. We get the hash of this. This should just be 1, 0. It's not in our visited set. So cool. We can also keep track of that, I suppose. This won't work if I do this. Yeah, it won't work. There's some other way to do this, and I never remember what it is. I'll just look it up really fast. JavaScript converts set to array. It's like array.from. Yeah, array.from. Yeah, so now we can see 1 zeros in there. So the gold on this tile is 0, or no, it's 6, right? We already said that. The neighbors here, we have 3 of them. But when we go through all 3 of them, we're going to find that 2 of them have 0 gold. This one and this one. And then the next one has a certain amount, 8. Yeah, so we push that as our node to visit. It's our only node to visit. We go into our next thing up here. And now our node to visit is 1, 1, and 14. Perfect. So this is as far as I got when I was drawing everything out manually. And then I said, this is going to be too much work to keep doing manually. So let's see where we go now. So we get the neighbors of this. And we're going to find the neighbor we already went to. No, this isn't right. Oh, whoops. I see my mistake. Debugging is helpful. So X and Y are parameters of the function. And when I'm saying X and Y here, what I meant is node to visit.x, node to visit.y. Yeah, whoops. Okay, let's try running that now. Hey, it worked. Okay, cool. So that was the one thing I had wrong. Where's the line of code here? Yeah. Grid nx ny. What's this? Canary property 1 of undefined. This means that we return something that's out of bounds. Huh. Wonder how I did that. Because this code should be stopping that unless the width and height got passed in incorrectly. Oh, this still says grid. What's that doing there? I must have deleted it only from my local file. Oh, well, this isn't going to be a problem in a real interview. This will be, which is just getting the wrong answer. So perhaps my thing doesn't work. Expected that we got 60 from this, and mine didn't. Oh boy. Let's see. What does this look like? Let's just do this. Okay. So we're supposed to have gotten the answer 60. Where does 60 even come from? Let's see. 3, 4, 3, 5, 6, 7, 4, 2, 20. It's 54. 7, 6, 6, 7, 4, 2, 20. It's 52. Well, no matter what, it definitely involves the 22, 4, 7, and a 6. So the question is, where do we go after that? And I guess it's 5, 3, 4, 1 is 16. What is this equal to? 39? I can't even figure this out by hand. I don't know. Maybe it does involve the 20. Yeah, I don't know. But I definitely have a mistake in my code. Let's see if we can just detect it by looking at the code. Because if I'm trying to find the most gold you can get starting at a particular tile, and I'm trying it on every single tile, then this shouldn't be an issue. So it would mean that this is an issue. Maybe I'm not counting the final bit of gold somehow. I don't know how that would be possible. No, yeah, I don't know. All right, well, let's look at the solution. I guess I give up on this problem. Yeah. No, this looks ugly. Also, let me read chat too. Hey, Squid. Did you say something about prepping too much? Doing too much prep and falling down that rabbit hole rather than actually doing interviews and getting a job? I might have talked about this. Yeah, but I don't remember what I said. I think that at this point, I mean, interviews are scheduled. If you check out the job hunt command, you'll find out a little bit more. So it's like, what's the best use of my time? And I think it's still just prepping. Can you skip any square that has more than one numbered neighbor? Mm, yeah, maybe you can. Is the cell the I array or the IJ element? It's in a matrix, so it should be the IJ element. Yeah, it's nice that it's included though. I like that. The visited nodes hash is not going to work if there's the same value in different cells. The hash is based on the XY coordinates because you can see I'm doing a two-string here, and that's what I'm using as the hash. So there's no way in a grid for this to ever be the same as any other cell in the grid. If I were doing it based on gold count, you're right, that could be the case, but that's not the case here. Yeah, it was just multiple cursors. Hey, Ski Dog. Rarely get to see you anymore. You're building something to prove your prep can be applied. For the companies I'm applying to, they don't look at that pretty much at all. So I don't think that's true. Hey Vlad, my day's going pretty well so far, I think. Yeah. So I'm I still am not totally sure what I messed up, but it looks like everyone kind of did the same thing here. Just some DFS. Thanks, Kangas. Appreciate it. Since we have no more than 25 cells of the gold, a straightforward DFS should do. Still wonder what I messed up. Yeah, I wonder what I messed up. Because in theory, what I did here should work. We could just go through every single cell and then see which path will get us the most gold. Huh. I just must have messed up something in here, I guess. I don't know what yet. Make a new node with path. What's the visit dot length is greater than 0? That's fine. Get the node that we want to visit. Get its hash. Make sure we haven't already visited it. Then add it so that we don't visit it again. Get the gold at this thing. Make sure that we're keeping track of the most gold we've ever found. I wonder, out of curiosity, what? Okay, so first of all, if I save this, yeah, and then out of curiosity, just what if we put this here? I just want to see something. Well, that's gonna break this. No, yeah, okay. I just making sure. I'm not going crazy with that. Then we go through the neighbors here. We get the neighbor's X and Y coordinate, which I believe I typed correctly. Yeah, it looks like it. Greater than 0, less than 0. So, yep. If it's 0, we don't do anything with it because we can't go over a 0 cell. And we push a node with the right amount of gold there. What have I missed? Oh, NFG, I'm not disagreeing with you. I'm saying for the companies I'm applying to, which is Microsoft, Amazon, and Google, that they're not going to care. And if you work at one of those companies, I'd be very surprised that you have the freedom in your interview process to do that because they're very standard to these companies. Neighbors are always visited in the same order from a given start position. That should be fine. Oh, wait. Oh, I know what I did. I'm not comparing. Okay, I see what I did. I'm not comparing whether this is part of the path so far. I'm comparing whether this is part of any of the scene neighbors. That's what I messed up. Yeah. And the return would be a continue if this were a native for loop, but this is a for each loop. I hate really. Yeah. So I see what I messed up. I'm going to give you a point. Yeah, that's too bad. So we need to keep track of a path for all of these so far, which granted my code had already spiraled out of control. How to go from I really don't have a preference to those. I used to have it in the job hunt command as of like this morning, which means that it should still be in the revision history. Although I don't think there's too much of an explanation, and in the time I'm going and searching this, I could probably have just told you. But I I just tried to figure out what would be the best for me. Yeah, version history. No, not that. C. Here it is. Click. Yeah. So it was just whatever I wrote here. Is this even helpful? Yeah. So I was saying I think that the best for learning is a combination of like good engineers plus tech focus plus opportunity plus impact. And I guess resources in there too, which kind of fits an opportunity. Yeah, I do use QWERTY. Yeah. I tried caddies for Code Challenge. Think you'd like it? Haven't heard of that, no. And thanks, Miyazaki. Can web developers be called software engineers? This is all based on whatever enough people agree on, unless there's some legal definition, in which case you go by that. So I don't think the question really matters. Makes sense. Did you want to keep it small? Interested why you didn't choose all of Fang instead of just those three? So I've kind of talked about this, and I said I wasn't going to talk about this too much more. So let's just say Facebook is a no by me. Apple is like a soft no by me. And then Netflix is just not around here. And yeah, then that leaves Amazon and Google. And I guess Microsoft, if you count that as part of Fang. Did you do the online assessment and phone screen for Amazon? Then phone screen. I don't know if there was a phone screen after that, but I did the online assessment. NFG, you're entitled to your opinion, but I would ask you to try to keep things at least productive in this chat. Interview with Microsoft where you got the job at Google. I see. Yeah. So yeah, I did the online assessment, and then they had these calls set up with the recruiters that I'm not totally sure who they're helpful for. It seemed like a lot of time spent in each call just kind of talking about stuff I didn't really need to know. Anyway, yeah, so I botched this. I want to understand though, what are the solutions that they had here? So what do they do here? If it's less than 0, so basically if it's out of bounds, just return. Otherwise, set this now has negative gold, which is what they check here. Okay, cool, that works too, I guess. Otherwise, the max of DFS of all of the neighbors. And then set it back to positive gold. Interesting. This is very clever. You mark the node as visited just for the sake of the next DFS, then you mark it as unvisited. Mm. Yeah, the thing about needing a license or something, that's why I said it's basically it's terminology until it isn't, and the until it isn't part is basically the law, right? So there's probably something in most countries preventing you from just saying I'm a doctor and then going and doing whatever you want. And so there are some places, and I don't know about Washington State, but I'm pretty sure Oregon is one of the states where if you call yourself an engineer, you actually need some certain education or requirements. I don't know what. I'm not claiming to be an expert on this stuff. I'm just saying that for most people, it's like, it's just terminology. And for some people, it's the law actually has a definition for it. And hey, Storm. Okay, so let's move on from here. This is clever. I definitely want to write this down. Where is this? I don't see it. I wrote so many notes. Do I have DFS written anywhere in here? Not in that section. Yeah, I don't. Do I have like pathfinding or something? Tree problems. I mean, you can kind of look at a matrix as a tree problem if you want. Yeah, no. All right, well, then we'll just write it. DFS, BFS, pathing, tree problems. So a clever trick to make it so that you don't have to keep track of the entire path that you've traversed so far, e.g. if backtracking is not allowed, is to mark the node as visited just before you continue the DFS, the search, then mark it as unvisited right after. Actually, wait a sec. How does that work? They mark it as visited, then they go to the next thing. Yeah, this is basically like magic. This is very clever, but it's tough to even see that that works. Would I be relocating? No, no, I don't think so. Yeah. So to clarify, because yeah, my what I was searching for has changed over this time. Originally, it was basically just remote positions, and then I said, well, you know what? If it's close enough to where I live, that's fine. So the companies I'm applying to all have positions within like walking distance of me, and if it's possible that I get a job at the company, but it's not the one within walking distance, in which case it's still not too far. But yeah, I very much value a short commute. Yeah. Okay, then mark it as unvisited right after. For an example, look at what's this called? Gold path with maximum gold. This solution to path with maximum gold. I'll just link the whole thing. Could you explain how you use your knowledge in studying notes? How do you review? Do you just pick a random topic on a certain day? For reviewing my notes, I tend to do them as needed. So, for example, for the interviews, I'll probably spend some time this weekend just kind of looking through my notes. But in general, for something like this, where where can you find the notes right there? For something like this, where you see me studying every day, and you might wonder, like, how is he even determining what to study? I think that's where the mock interviews come in handy. Now, granted, this is for interviewing, so it makes sense that for the mock interview, I'd find out the interview process, but this could change for other knowledge. And so the mock interview process for most people is going to uncover some gaps, and then you just go approach those gaps. So for me, it was kind of like momentum in coding problems. I feel like I have enough knowledge at this point where the interviews shouldn't be a problem, but it's very easy for me to get dejected after finding some like misstep, and then I just can't get back on the path. And that is intensely bad. Like intensely bad. That's what happened last Thursday. If any of you want to watch a total train wreck of a stream, you could watch either one of Thursday's streams last week. Yeah, they were both really bad. July 30th, yeah. Neither one is worth it. But I got to stop that from happening in the interview. Thank you, Thoros. Thank you. Well, let's keep going. But in the interest of keeping momentum, we're going to go to an easy problem now, because that's what I said we'd do. If I ever don't get a medium problem, we'll just go to easy. So where do we leave off with these? I think I was starting from the lowest accepted ones. That doesn't make any sense. Oh, because we're on like page 4 or something? Yeah, that's fine. Okay, so I've gone through a lot of these. Where did we leave off? Number of segments in a string. Let's do this one. Count the number of segments in a string where a segment is defined to be a contiguous sequence of non-space characters. No, the string doesn't contain any non-printable characters. I don't think this is interesting. I mean, I would do this one with just like a regex and all the non-space characters. But I think they want you to iterate over it or something. Either way, it's not an interesting solution. So let's just move on. Factorial trailing zeros. Given an integer n, return the number of trailing zeros in n factorial. Your solution should be in logarithmic time complexity. Okay, let's look at this one. I don't know if this is going to be interesting. So do this in log n time. If you were to just compute n factorial, what time is that considered to be? O of n, I guess, because it's based on the size of the input. But it's actually more than that, right? No, it's not. It's just O of n. Because you're iterate from, what, 1 to n? Technically 2 to n, I guess. 2 to n, and just keep multiplying. So if that's O of n, how would you do this faster? I guess what's the only way you can end with zeros is if the prime factorization includes 2 times 5. A certain number of times. Can you skip that? Like 6 factorial is what, 720? What am I doing? 4 times 3 times 2 is 24. Times 5 is 120. Times 6 is, yeah, 720. Yeah. So 6 factorial is 720. 5 factorial is 120. Every single other factorial after this is going to end in a 0, at least, because of the 5 factorial factoring out to 5 times 2 times some other stuff. And so eventually we'll get up to 10 factorial, and that's going to be 2 times 5 times 10 times some other stuff, which will be 2 zeros. And it's only going to be every time we do that, right? So like every 5 that we hit is going to add another 0. Is that right? I mean, the factorials are going to get pretty large. Let's look at 10 factorial. This should have, what, 2 zeros? Yes. And then 15 factorial should have 3. Yep. And then 20 factorial should have 4. Yeah. So we could just, can we just divide? Isn't that not even logarithmic time? I'm pretty sure we can just divide and do it in constant time. I'm gonna write this out. Maybe I'm totally wrong here. If n is less than 5, return 0. Otherwise, return n divided by 5. Not 4n divided by 5. I've gotta be missing something here, I feel. All right, so the input is 30. The output's supposed to be, oh, because there are multiple 5s that could be in there. So like 25 is where this will jump, right? Because you have, yeah. Yeah, so 20 had 4, but 25 is going to have 6. Yes. Okay, that's the mistake I made. And every power of 5 is going to mess that up. And I guess that's where the logarithmic time comes in. All right, except for I don't know what the best way of saying this is. So every 5, we add a 0. Every 25, we add a 0. Every 125, we add a 0, and so on and so forth. So we just keep doing log base 5 of our answer. That's how we're getting this. Okay, I think I understand. So how do we do that? I don't know. I don't know. Because it's not just, oh, we need to add that power of 5, right? Because this is every 5 to the 1, we add a 0. Every 5 to the 2, we add 2 zeros. Ah, I see. This is what makes it easier to understand now. Every 5 to the 3, we add 3 zeros and so forth. So we just do, does JavaScript even have a way to do log of a certain base? I have no clue what this is saying. Yeah, I don't know. Can you specify the base? Oh, right. The log of anything. Okay, yeah. So we can just copy this, I guess. All right, so we want log base 5. Five. That's right. So we put the 5 first. So just delete this. Yeah, that's probably right. I'm gonna struggle through this. What's going on? There. Get log base 5 of 120. So this should be 3. It's roughly 3. This is 2, and then what's the next one? 625. It's 4. Yeah. So now, how do I test what I wanted to test here? I want to get the power of 5 that this is. I want to get the biggest power of 5 that fits into it, and then multiply by the number that I had, and then lower it, then subtract. Yeah. That's what I want to do. Okay. So while n is greater than 0, biggest pow 5 equals math. Oh, no, not math. This. Biggest 5 of n. So let's say we had 130. This is going to return 3. So we're going to say let num zeros equals 0. Now we probably don't need this case at the top. I'm just going to keep that there for now. Num zeros plus equal the biggest power of 5. And then n minus equal math.pow 5 biggest pow 5. And that's it. That should be our code. So I'm not going to test it. I'm not going to look at it too much. I don't think this is going to be an distribute problem. Yep, just got negative 1,143. What? What did I do? So we had the number, what, 30? What's 30 factorial? 25 factorial is 6. Let's just take a look at that one. Yeah, I'm clearly seeing what I had done wrong here. I messed up my formula somewhere through this. And I think I've got all the pieces. Oh man. All right, what did I want? I guess like n equals 25 should be 6. Where are all the other ones I had? N equals 5 is 1. N equals 6 is 1. 10 was what? 2. So that means that 11 is 2. 15 is 3. 20 is 4. 25, yeah. So anything between these two is going to also be 3. Yeah. So the formula I messed up. You know, let's just write out the test. Just easier. Trailing zeros. Just gonna write out this whole list. Who cares? So 5 should be 1, 6, 7, 8, 9, 10, 11. And then we're going to write out some of the other ones now. 15 is 3, 20 is 4, 25 is 6. And clearly this is going to be very broken. paste this into here. There we go. So that fails pretty early on. Because we're ending up with this just messing up. This is supposed to be mat.floor log base 5. Okay, and it's only at 25 when this starts to break. And the reason why is because it's supposed to be the number of 5s that were in 25 plus the number of 25s. There's probably a better way to do that. Six. 5. Yeah, 6. I am not sure. Yeah, I'm not sure. I think we can put another while loop here and say something like, well, biggest power of 5 is greater than 0, and do something and add number of zeros equal to this, and then like I don't know. I think I'm gonna stop now for this one and just look at the solution. Cause yeah. All right. Where did we leave off? Reading chat. Here it is. Yeah, I think this is a lot of what the interview process is like. Oh, let me turn off that notification. There's a lot of what the interview process is. It's realizing we have gaps, then getting frustrated that you never really feel like you've got a grip on it because there's an infinite number of problems out there that people come up with. Not really infinite, I guess, but still. Probably if you were to scour the internet, you'd find like 30,000 problems. And there's no way you're going to do all of them, right? I want to learn programming web graphic design. What course would you recommend? Programming web graphic design. I'm not sure if you're listing out 3 different things, like you want to learn programming, web, and graphic design, or if you want to learn programming on the web for graphic design. But in my mind, graphic design is very separate from the programming stuff. Anyway, I think the general skills you probably want to get are like HTML, CSS, and JavaScript. And so I'd start with those. As far as courses, I don't have any in particular that I know about that would teach those sorts of things. Had a 48-hour test. What does you mean? Like you had 48 hours to do it? Problems had these time constraints: limit 1 second, memory limit at 1 gig. I see, Miyazaki. Yeah. What company was this for? Yeah. You only have to check n if n% 5 equals 0. Yeah, that's true. Although you still, I still messed up the rest of this, I guess. Yeah, I'm using JavaScript. The wait what is just because of how floating point math works. Yeah, there actually used to be a bug in calc where you'd say like 2 plus 2, and then you'd say the square root of this, and it wouldn't actually be 0. They probably fixed that specific bug, but it used to be that it'd give you some like wacky number there. Oh, wow. Yeah, this sounds like a lot of time that you had to spend on that. Oh, local telecom, got it. You develop it. Yeah, I could do this, but then I was thinking, I don't know, it seemed tedious. So maybe that's the right answer. I thought there might be some like way more clever math solution where you could boil this down to just one line, I guess. Anyway, I think I had the right general idea and just didn't keep looking at this. My one line solution. Yeah, that's clever. Well, too bad I didn't get it. Oh, I see. Ski dog. Got it. My bad then for explaining that. Yeah, let's look at valid boomerang, I suppose. A boomerang is a set of 3 points that are all distinct and not in a straight line. Given a list of 3 points in a plane, return whether these points are a boomerang. This doesn't seem like an interesting problem, but I kind of want to try it anyway. A set of 3 points that are all distinct and not in a straight line. So 3 points, all distinct, not in a straight line. Given a list of 3 points, determine whether they're boomerang. So, okay. Sounds like we could say like R points equal P1, P2, return P1, 0, and so if R points equal points and R points equal points 1 and points 2, then return false. So they can't be equal. That's the first thing. And then they have to not be in a straight line. So to figure out if they're in a straight line, the slope from 0 to 1 would need to be the same as the slope from 1 to 2. Yeah, I think so. Slope 1. So how do we figure this out? Let's say we've got a point here. Let's just say we have a point at the origin, because we can always align these to the origin, and then we have a point up here. So the slope is going to be just this, which I guess we could get the angle of that. So y2 minus y1 over x2 minus x1, and the arctangent of that. That might be right. I don't know. I'm just gonna code that. I don't really care. I don't think this would ever be an interview question either. Math dot, is there an arctan? A10? A10. And there's A10 too to account for when the denominator is 0, I think. All right, let's try it. A10 to points 1, 1. That's 0.01 divided by points 1, 0 minus points 0, 0. And then slope 2 is just this, which I probably should have written a function for. I'm just going to submit that. And I don't really care if this is wrong. Yeah, I'm just going to go look at the discuss right now. What do we do? Calculate the area of ABC. You can reuse a conclusion and prove largest triangle area. All I want is to calculate the slope. Oh, we don't need the A10 because I guess that's just the angle. So we could have just done this as the difference with the thing go. So we get rid of this and this. Is that wrong? You might have still messed that up. Yeah, like I said, I don't really care. Because we're not gonna get this in an interview, and it's not a big deal. I don't really consider this as a loss. Make a new string and place dot on positions where they're different. Place minus where they're the same. Oh, going to ramped up quite a bit. Make shortest path from a given number to another given number. Prime numbers are walls. Yeah, it's pretty crazy. I got a question a long time ago for a game company that was like, find the intersection between a sphere and a cone or something like that. And I was like, oh god, I have no idea what I'm doing here. So I had to look up a whole lot of things, and then I came up with a solution that worked. But it was like, let's say you just had to add 2 numbers. and you're like, oh, you know what I'll do? I'll do add the two numbers and then subtract like half of the y, and then add in 2 times y, and then subtract another half of the y, and it's like, whoops, this is supposed to be a 1. This is correct. This is also how you'd add two numbers, but this is obviously like way more math than you need because this is all superfluous. And so I was probably doing a bunch of that stuff, and they're like, it's okay enough. We'll let you move on to the next interview. Yeah. Maybe it wasn't exactly that. It was something that was like crazy for me to try to do. And I don't remember exactly what it was, but it was something along those lines where I like couldn't even picture this in my head. And yeah, I did not like it. I also don't remember what the job was for. Like I said, it was a game company, but I don't know if it was for like the renderer, the game engine. All I know is I could not have done that if you just sat me at a computer. I would definitely need to look things up. Wait a second. Subscriptions don't even exist on this channel anymore. I guess welcome back anyway. Thanks, why not? You're potentially the real last person to reshare their sub. Check if n and its double exists. So far we've been getting stuck on some of these easy problems, but these easy problems haven't really been real interview problems, I think. What happened to subs? I turned them off. I don't want your money anymore. Get that money out of here. Okay, given an array, I'm going to do this one next. So let's take a look at this. Given an array of integers, check if there exist two integers n and m such that n is the double of m. More formally, check if there exist two indices I and j such that they're not the same, and yeah, okay, that makes sense. So n is the double of m. Okay. This seems pretty straightforward. So we've got option number 1 is just brute force, just check every pair of numbers. Option number 2, we could sort the numbers, and then, or no, what we could do is we could iterate over them once and add the target that we're looking for to a set. And then if the number we found is in the set already, then return true. Yeah, I think this is the best way. So let's just do that. This should be super fast. I'll move on to something else. So we'll say like targets equals new set, let I equals 0. All right, so let's write so our target for this is going to be, we want the double of it. So num equals array I, target equals num times 2, targets dot add target. Right, so if we find, I guess it could be either one. We could either find 20 or we could find 5. Yeah, so we could say number times 2, which will always work. And then if the number itself is even, we could add num divided by 2. And then get rid of this. And then check if our number is in this. If targets.has num, return true. And then here return false. I think that'll work. I'm not going to look it over. Yeah, that works. It's great. Is that what other people say? Hash set with analysis, 5-line solution, Python counter. What's this one? Count everything. Check if there are more than 1 0. Oh, okay. Yeah, that's not a particularly tough problem. So I'm going to move on to the medium ones again. By the way, the reason this is why knowing what problems are similar to is really important. There was this Google video, by Google video I mean the video Google put out about interviewing, and they had a sample interview question of, you're given an array of numbers. I'm going to get this wrong probably. And you have to see, you have a target value, and you have to see if any two numbers sum to that target value. And so that problem is so similar to this problem that you can pretty much just apply the same solution. But I mean, it's also an easy problem. So let's continue going with medium questions. And we left off on page, actually, we were doing it the opposite way. I was doing it by decreasing acceptance, and I think I was on page 3. Is this for the programmers hang out? Yes. We are grammarians in this channel. All right, where we leave off. We did this one. So the next one would be keys and rooms. Yeah, this looks good. Let's do this one. All right, I'm going to put this little notification back up. There are n rooms, and you start in room 0. Each room has a distinct number up to the length of the number of rooms. And each room may have some keys to access the next room. Formally, each room I has a list of keys, rooms I, and each key, rooms ij, is an integer, where, and yep, this all makes sense so far. A key opens, yep, cool, great. Initially, all rooms start locked except for room 0, and you start in room 0, right? Yeah. So you start in room 0. All the rooms are locked. Each room has keys to other rooms. You can walk back and forth freely. So return true if you can enter every room. This is a super cool question. I like this so far. So let's see. This one's true. We start in 0. That lets us move to 1. 1 lets us move to, I'm going to say this wrong, to 2. 2 lets us move to 3. And 3 doesn't have any keys, but also everything's open at that point. And then here we can't enter the room with number 0. Or sorry, we can't enter the room with number 2. This one. Because that's what, 0, 1, 2? Yeah, because the 2 contains a key to itself. So this is kind of like finding islands. So we essentially, we have potentially cyclic graphs here. And our goal is to see if all nodes are connected. Because, yeah. Okay. So if we draw out a graph, there's probably some graph algorithm for doing this much more easily. But here we have 0, and that goes to 1. Doing this right? I just want to draw the graph that represents this whole thing, and that goes to 2, and that goes to 3, and there are no other arrows. And so here we have 0, and that goes to, well, we always have like 1, 0, 1, 2, 3. Yeah, we have 3 here. So 0 goes to both 1 and to 3. 1 goes to 3, 0, and itself. 2 goes to itself. And 3 goes to 0. So it's very easy to see as a human that the cheese stands alone. This thing is not accessible because there are no arrows that point to it. So I guess that's kind of how we figure this out. We need to make sure that's not as simply said as how I just said it, that there are no arrows pointing to it. There actually is an arrow pointing to it. It's just from here, but that happens to be an island itself. I guess we can kind of backtrack from each node. And if there's no path to 0, then we return false. So let's say we start, backtrack from each, I guess, non-zero node. And if there's no path to 0, then we return false. So here we just ignore because 0 is unlocked by default. So we look at 1, and we see there is a path from 0 here, so that one's true. Then we go to 2, there is no path from 0. And then we go to 3, and the only path from 0, well, actually, there are 2. Let's consider another graph that's maybe a little bit harder. 0, 1, 2, 3. Let's say you had this. So this is also true, but the only way to figure out that it's true is to go through all the nodes that we had there. Can we just kind of BFS our way out of here and not go to nodes we've already visited? I think so. Yeah, I think so. Oh man. But no, the order matters, right? But that's okay. Yeah, that's okay. I think that's fine. All right, let's write this one out. I'll do this on my own computer for now. LeetCode here. All right, so this input is true. So we have rooms can visit all rooms. And then we have the next one is false, right? Okay. So our rooms are a set that we have. So we're going to say something like return how am I going to do this? We could say like, I guess in marking that they've been visited already, we can have a list like visited equals new array rooms.length dot fill with false. And then visited 0 is going to always be true. And then we say DFS with all the rooms and visited, and then return find visited false equals null. I don't know. Let me see if that's how that works. This isn't really, this isn't like part of it. I could write this more easily if I felt like it. Return the first element, predicate returns truthy4. Now I might have to say something like the otherwise, what does it return? Who knows? Probably null though. Okay, so now our DFS function. This takes in the rooms and our visited set, and I guess also a starting point. I wrote 0 in the wrong spot. This is like current room or room number. Okay, so what are we doing here? We are, actually I was gonna write this as a BFS. Doesn't really matter which direction I go in first. So we get the neighbors, so we're gonna say something like rooms to visit equals room number, while rooms to visit dot length is greater than 0. Room to visit equals rooms to visit dot pop. Okay, so if we're gonna mark this as visited, actually we don't want the visited set to contain anything at first. Yeah, just delete that. That way we can do the same thing we had done here. So if visited room to visit, you know what, let's change this a little bit. Initial room number, that way I can call this just room number. I think that's a little bit easier. So if this is the case, just continue. And now we want to find out where we can go from here, and that's in rooms. So next, so like neighbors, I guess, is rooms, room number, and then we push all of those. So for each neighbors, rooms to visit dot push n. And that's it, right? Now we just need to mark that as visited. I think that's it. I'm going to look through this one really fast. So we start out, we have an array of a bunch of falses based on how many rooms we have, and we're going to start at room 0. So we're in room 0, and now rooms to visit has nothing on it. We mark it as visited. We go to all the rooms that it can lead us to. Yeah, I think this is fine. Let's run it. Yeah, it worked. All right, now let's paste this into here. Okay, yeah, that was fine. Yeah, fine. I don't really have anything else to say. Yeah, this should be an easy question. All right. Yeah, just check everything's visited. Yeah. Can we basically just ignore self-references? Yeah, we can. Yep, yep, yep. You go 0 to 3 if you have key 3? Yep, you can. Well, that's not really super important to this of whether you'd have to go through room 0, like 1 doesn't connect to 3, but 0 does, let's say. If there's some like lobby area and they're all off of this lobby, it doesn't really change the question. What would change the question is if there was a cost between certain nodes. So like 0 to 2 was twice the distance of 1 and you only had to do it within a certain cost, then that'd be a little bit harder. Take care, Smurf. Besides knowing one of these programming languages, are there any good knowledge, any topics or knowledge that would help someone who's also trying to solve LeetCode problems? Or are there virtually not prerequisites? I don't think there are any prerequisites as long as you're okay with looking up some of the solutions when you don't know them. So I think a good example of this is just finding a cycle in a linked list. This on its own is just one technique, and it's called Floyd's tortoise and hare algorithm, I guess. Or at least that's one way you can do it. Maybe there are other ways, but it doesn't matter because there's at least one. The first time you do this, you will probably try to think, okay, how do I go about doing this? You're kind of going to be reinventing the wheel because someone's already done it and someone's probably done it better than how we'll try to figure it out our first time doing it. So in that sense, there's no prerequisite to trying to solve a problem where it literally just says like, given a list, detect if there's a cycle. So this would be labeled as an easy question probably because it's just testing, do you know this as a technique? Eventually, when you have learned all of the techniques, it's clever ways of combining them and realizing when to use what. So if you want to just focus on those, the fundamentals, there are a lot of CS courses out there about algorithms. One of the ones that I had looked at was this one. So this course is called Introduction to Algorithms, and it's by MIT. And I think, yeah, there are multiple professors, but this guy, the one in lecture 2, lecture 7, lecture 8, he's really good. I really liked him. I did not actually watch any of the other lectures because I only watched the dynamic programming ones, and all of those were just the same guy. So I thought he was really good. Presumably, he's good in all of the lectures. He apparently got his PhD at like 20 years old. So the people I've met who've gotten their PhDs at very young ages have been very smart. The other guy I thought was a very impressive guy as well. I don't know if I talked about him too much, but he was a guy I met through First Robotics. The long-haired guy's a mega genius. Yeah. He's pretty smart. Has part 2 of the day been better? Yeah, it's been better. Yeah. Knowledge is proportional to the length of his hair. Yeah, and then there are probably some good books. I have not looked at them too much. There is one other thing, Fled, that you might find helpful, which is this resource, which links to 2 other resources, which might be what Ben is talking about here, but I'm not positive. This is a 60-page document. Its entire goal is to make you feel like you need to do tons of work. Brock Sampson? Wow, I haven't heard that name in a while. Be crazy. Okay, let's do another problem. So what's next? Where did we even leave off? So difficult to tell. Keys and rooms. So next is single number 3. No, not Brock Sampson. I don't know the biblical Sampson. I know the Brock Sampson though from Venture Bros. Anyone link that course one more time? I have my chat closed. Yeah, let me go find it. Here it is. Oh, wrong person. From Venture Bros, says Dr. Boyfriend, whose name could not possibly have had anything to do with Venture Bros. Okay, so here's the next problem we're going to do. Mark that. Given an array of numbers in which exactly two elements appear only one. Oh, I tried this one, didn't I? Or maybe it's very similar to another one. I don't know. This is the third in the series. Only once, and all the other elements appear exactly twice. Find the two elements that appear only once. Order is not important. Algorithm should run in linear time. Could you implement it using only constant space? Any array number problem that says use constant space is some math trick usually. Very rarely does it turn out to. Oh, wait a second. No. There was a trick earlier where you were supposed to use the input array as your extra space. Oh, what if we did that? Suckers. Didn't think I learned the pattern, did you? Okay, so how do we find the numbers that appear exactly once without using any extra space? Now, this is very important because the way I interpreted this earlier was that we can't use any space, but it was extra space. So we could use the input array to store things if we needed to. They also said do it in linear time. So we tried technique number one, which is calling the problem a sucker. So the next technique we're going to have to do, if we kept track of where we found a number in the list already, I wonder if that'll work. So yeah, what if we track the first index of the number in the list? We expect them to go through once. Something like that. We could tell something's duplicated maybe? Let me think about this. Let's say we had 1, 2, 2. The answer here is 1. Well, it's the array 1. And so as we're iterating over this, I guess we say that this is... No, it wouldn't work that way, would it? Unless, no, they're not sorted. Yes, we might have like 2, 1, 2 here. Some way we could do this. They did something where they like subtracted the... I don't know. It doesn't matter what they did in the other problem. I should try to figure it out for myself. We got to use this array as we're iterating over it. Find out where this thing might be wrong. So I guess we have the first time we encounter a number and the second time. How would we use that to help us though, unless we were putting things in the right order? By the way, the way you would do this without the constraints of the problem is just keep track of a set of frequencies and then just see which ones only have 1. Like that'd be dead simple. But yeah, I'm not figuring out how to do this in the constraints that they gave us. We somehow have to use the input array for our extras as our extra space. But what do we store? It's not sorted, so we wouldn't know where to look for data we stored about a duplicate number. Maybe we can sort as we go. No, we can't. Because you have to do one pass. If we look at the number 1, we can only modify that position to do something. Yeah, I wonder if we set it to negative somehow, if that would help us. Then the next time we find this. No, I really don't have any ideas here. I think this is where I probably should have figured out what we're supposed to do from the earlier thing, but all I really took from it was we can use the space we were given. Which, while that's true, I don't know how we're supposed to use it. Is there a way we could do this without even using that space? I wonder. Because earlier I was testing this with, like, can we figure something out from the sums or the products? And it turns out the answer is no. I'm just guessing the answer is no here too, even though I didn't try it. But it wouldn't be that hard to test, I guess. We have something like 2, 1, 2. Now we wouldn't know from just a sum, because the sum is 5. I'm not going to try this path again. I don't think it's the right path. Now, what do we store? Can we know? No order. There's no order. We can't sort them. We have this one array. We can't extend the array. Otherwise, it'd be that simple. We could just make another array on it. Oh, I don't have an idea. Nothing has struck me. I kind of want to look at that other problem to see how they solved that one, because I feel like it's the same technique. But I feel like that's also cheating. But if I'm otherwise stuck, I guess there's no real reason why not to do that, right? I think it was this one. Did we solve this one? Apparently, no, we didn't. No, we didn't do that. What about this one? Could have sworn there was a problem we did earlier today. No, I didn't do either one of these. But it used the same technique. Was it? Reveal your secrets problem. And there was another problem even beyond this where it turned out to just involve some if statements and I didn't realize. So maybe like I kind of ruled out a math solution, like no summing products, etc. I don't think that's kind of the way here. Is there some other thing we can do using just if statements? What if we okay, what if we know as we're iterating over this which ones we've already encountered, right? So what if we somehow use that to keep track of the data we might want? How would that help us? Like what I'm kind of thinking here is we have 2, 1, 2. No, that wouldn't help us. It only help us for nodes we encounter prior in the list, which would mean that they'd have to be sorted. Oof, I don't know. I definitely don't know. Yeah. I don't have any ideas. I don't know how much longer I'm going to look at this waiting for something to pop out. It's like those 3D eye puzzle things. You just stare at it, and all of a sudden you see a boat. There's no boat here. Yeah, I don't know. I guess I'll have to look at the solution. It's too bad there's no hint, though. Man. Easy solution. XOR all the elements, get the XOR of 2. Oh. Interesting. Okay, well, let's keep reading because I hadn't thought of XOR. XORing the last one would have been a bad idea because I think what we were looking for was single numbers. Or, I don't know, there's some constraint where I tried XOR and it didn't do what I wanted. I just ignored it here. Anyway, get the XOR. So all the elements in the array and get the XOR of the 2 numbers we need to find. Wait, were there only 2 this whole time? I think I might have also misread that. Description. Oh, man. Yeah, because if we, okay, so anything XORed with itself is always going to be equal to 0. So we have a whole bunch of numbers in here, and some of them are repeated. So when we XOR all of those, they're going to be gone. And so if the numbers we're left with are like 1 and 3, we're going to end up with the XOR of just those values, which I'm not actually sure how that helps us. But let's keep reading. There must be a set bit. Find out an arbitrary set bit, for example, the rightmost one. In the second pass, we divide all numbers into 2 groups, one with the bit set, another with the bit unset. 2 different numbers we need to find. Wait, what? two different numbers we need to find must fall into the two. This is incredibly clever. I never would have gotten this. Yeah, never would have gotten this. Yeah. Oh, never would have gotten this. All right, let's see. How's everything going? It's going well. Yeah. And I had no idea, Links. Thanks for filling me in. Constant space allows extra space. Constant space does, yeah. And almost no problem that's interesting is going to allow you to use no extra space. Like you can't even define a variable to be the sum of two numbers or something. Like that's not going to be the case usually. But yeah, constant space. And how do you do this if you return an array? You're given an array. So um, the array that you're returning, I guess, is just. Oh, sorry. Yeah, I see what you're saying. Yeah, you have to return the array, but the array is always of two elements, which means that it's constant space. So your input could have 1 trillion elements. You're still going to output 2 elements. This is constant. If your input was 1 trillion and that caused you to output like half of a trillion, then that's O of n space. Well, very likely O of n space. Like it's based on the input. But yeah, it's not in our case. Where's dark mode? If you're saying how did you get this, I think is in the settings gear, but if you're saying the rest of the site, yeah, I don't think it has it. And I think you can just use dark reader probably. Does it look like garbage if I do that? No, it's fine. Let's just do that then. I'll give you. As long as we're in the range 1 to n. Yeah, I don't remember the problem, unfortunately. This is something I remember when I first started watching Hearthstone, which was, I don't even know, whenever the game came out. Let's just say like 2015. I'm just making up a year. And I was really impressed because the guy I was watching at the time, it was Crip, he was able to be like, well, on turn 1 of that game, this happened, and on turn 2, this happened. And I thought, this guy's a genius. Well, now doing LeetCode problems, I have no recollection of the other problems that I did unless there was, I guess, something noteworthy about it. So the noteworthy thing from earlier was the extra space bit about how we can do something here, but even that wasn't really necessary for this. So I guess I didn't take anything. Yeah. Yeah, so Tug, you're right. Although please do try to not segment your message. Oh, I see. Actually, start. Jupiter said the same thing. Yeah. Time to finally learn how to code better. Welcome, Base. Yeah, Crip is smart. I agree. But I thought that alone was a superpower of like, here's what's happening with all the different turns. I mean, I eventually went on to play Hearthstone, and I realized that if the game only lasts like 12 turns, it's not too hard to remember. Okay, here's what happened on turn 3. But in my head, it seemed like it was, I don't know, some crazy feat that no one could ever replicate. So my new rule is whenever we don't get a problem, I'm going to go back to the easy difficulty so I can feel good about myself. I think this is maybe the most important part of studying, is not hating yourself by the end of it. It's actually a difficult skill, I think, with practicing for interviews, because the self-loathing comes through pretty quickly. So let's go back to, how have I been doing this? I've been doing it from low acceptance to high acceptance. So we got to figure out where I left off. Apparently we didn't make it to page 2 yet. Sorry, I know I'm scrolling all over the place. I'm just trying to figure out where I left off. Reverse segments, factorial trailing 0, valid boomerang, check if n and it's double exists. Classes more than 5 students. This is where we left off. If you can't get the easy one, then you go and just do basic arithmetic or something. Why don't I submit the code? Oh, I do, but some of these I don't end up completing, and I don't want to just mark as solved when I didn't really solve it. Like I didn't come up with the right solution, so yeah. Okay, let's mark this as the current problem. This got a lot of downvotes. Oh wait, that's a SQL problem. Never mind. We're not going to do this one. I don't know if it's a bad question or not, but I'm doing ones that I can code, not ones that are database queries. Yeah, this is a SQL one as well. Why are we finding SQL ones all of a sudden? And what did I just click? Rising temperature? What is going on? Why are these all bunched up next to each other? I don't have any other categories, do I? No. What's this one? This one's a coding one. Okay, well, whatever, I guess. Yeah, all right. So now let's do this. Remove all elements from a linked list of integers that have value val. Okay, seems pretty straightforward. All right, so we just iterate over the list, and if we find the value, then we connect the last one to the next one. And our list notes look like this, yeah. So, yeah. Let me write this out. Problem with linked list questions for me is that I always mess something up anyway. Like, these should be dead simple. That's why it's an easy problem. So when finding the value, set previous next equals current next. Yeah. So I'm going to write this in my own editor for now. So let's say previous equals head, previous equals null in this case, I guess. And while current is not equal to null, no, this was dumb. Put it back to plain text. Put it over here. Oh, well, the current is not equal to null. If the current, what's it called? Current.val. If current.val equals val, then we're going to delete this one. And we need to potentially modify the head of the list if we're deleting the head. So if current equals head, then head equals head.next. Otherwise, it's not the head, so there will be a previous. So we say previous.next equals current.next. Cool. Then we set current equal to current.next. Current hasn't been changed at any point, so that should be fine. And there's something else I need to do, right? Am I supposed to return something? Doesn't say to return anything. I guess we'll return the head anyway. I feel like I'm missing something. I don't know what. Oh, I never said previous. That's right. Okay, how's that? Looks like I've got an infinite loop. Yeah, which means I need to think about this a little bit more. Amazing how I still mess it up. All right, let's look at their example and just kind of step through it. They have 1, 2, 2, 1. You're supposed to remove 1, and we did not remove both of the 2s. Or so you're supposed to remove 2, and I didn't remove both of them. So we start current at 1. So this is not going to be the case. So we set previous equal to 1 and current equal to 2. Okay, good. Now the current is equal to that. It's not the head. So we set the previous next to the current's next, which is that 2. So we're basically going to be saying like a dot next equals c. And then the previous is going to be set to the current. No, not in this case. No, because we deleted it. That's what I messed up. So what's the best way to do this? One is to just keep track of whether we deleted it, and if so, set it to... actually, I guess we just set this here, just else. Yeah, because we didn't delete it. Okay, submit that. Cool. Well, I probably shouldn't have messed that part up. Because I think that should have been apparent, but yeah. Here, I know you guys can't hear the sub sound. Let me set this to. Nope, didn't work. There we go. Now, let me play the sub sound for real. No idea where it even is. There it is. Subsound.mp3. Blam. Anyway, welcome back, Rymo. Thank you for the resub. Yeah, late announcement. It has to be late announcement. Subs are turned off. No one's actually going to be a sub after another like 2 weeks. But thanks for having spent your money on this. So 3-line recursive solution. What was even the problem? Oh yeah. Okay, cool. How long have I been streaming for? It's actually been more than 2 hours. Wow. I wasn't really planning on being online for too long. Let's do one more problem. Yeah, one more. All right, so where do we leave off? Here, here, here. Palindrome linked list. Well, late stream, yeah, it kind of started late though. It's not like I just went late. Given a singly linked list, determine if it's a palindrome. Can you do it in O of n time and O of 1 space? Okay, so let's set this. I haven't had any interviews yet, Beck, so they have not gone yet, but they're set up for starting next week. So I've got my schedule, I think, here. Tomorrow I've got a call with Microsoft. It's not really an interview. In fact, I'm not really sure what the point of the call is, but I'm guessing they're going to ask for my availability, and then they're probably going to set it up next week. But then, yeah, next week, Friday, Amazon, then Monday, Google. So they're back to back as far as business days go, but I've got the weekend in between. And if I schedule Microsoft next week, I'll probably schedule it on Wednesday if I can. That way I've got at least a day in between. But that's going to be kind of tight. So maybe Tuesday, I don't know. Okay, so yeah, how do we do this? So here are examples. And we have to do this in, what were the constraints here? O of n time and O of 1 space. All right, so O of 1 space. Because I think the easiest way would be like set up the linked list in reverse and ensure that, and iterate over both to the halfway point and ensure that characters are equal. And there's a way to reverse a linked list in place. But the problem is we need to check if it's the same forward as it is backward. What if we reversed the... Oh, yeah. What if we reversed just the latter half? Yeah. What if we reverse just half of the linked list and then start another pointer there and march them forward until the second one hits the end? Yeah, I think that would work. So basically we have 1, 2, 2, 1. We reverse the latter half, so we end up with 1, 2, 1, 2. Then we start a pointer here and here, and we just slide them both along the list until we hit the end. And as long as the characters are equal, then we're fine. That would work, except for that this is really annoying to code. So I don't want to do this. Because the last time I had to reverse a linked list in place, I like totally messed it up. Yeah, so I guess we're stopping here. But yeah, this is what the solution I do is. So is this the solution that they suggest as well? Reversing a list is not considered O of 1 space. What? Input has to be read only. Why is that a prerequisite? Anyway, fine. I feel like that. Yeah, this is pedantic. But is that what people suggest for this anyway? Yeah, reverse the second half, compare the two halves, start with an example. Yep. Yeah, it's this code I didn't want to write. But yeah. Oh, these allow working from home outside of COVID times? Some might. I think it's tough to tell. Google, I think, just announced that they're going to be working from home until July. Amazon is at least until January. I don't know what the updated time is on that. And Microsoft, again, I don't know what the time is on that. But I don't think any of these tech companies are having people go in yet. I think just having all the interviews be in one day is enough to make it hurt. So I think having at least 2 days of break is pretty important. Well, that's it for this part of the stream. So I'll probably be back online tomorrow for some more practice. But honestly, I think the best thing I could do right now is probably mock interviews and just as many of those as I can cram in. So I might not stream tomorrow. In fact, you know what? How about this? I'll say I won't stream, and if I do stream, I'll advertise it on Discord. It's August. I meant July of next year. Sorry, I didn't say that. 2021. Because tomorrow I have a call at 9 a.m. So that's when I would normally be streaming. But yeah. So the schedule is going to be up in the air. I'm going to write myself a note. Delete tomorrow from stream schedule. Schedule is going to be up in the air for the next bit of time because I've got so many interviews coming up. I imagine there's going to be some gap of time between August 17th and either my next interview or just when I hear results from this and then potentially start a job. I don't know what those streams might look like though. So if you're at all interested in this stream, you should join Discord or follow, I guess. It doesn't make a difference too much. Again, I'm not out for money or anything. I turned off subscriptions on the channel. So thanks for watching, guys. Maybe see you tomorrow. If not, probably next week some point. But see you guys.